Hello, this is Algebra 2. We're looking at exponential graphs, and we're going to start today with a story about bunnies. We'll just go through it a little bit. I will not try to talk too much over it. You can read it and enjoy it yourself. Basically, you make lots of bunnies. They become a lot. And at the bottom here, you can see you have what we call an exponential function. We call that because it has the x, or the independent variable, in the exponent. And here we have the general format for an exponential growth function. The key here is that the b, or the base of the exponential function, has to be more than 1. So now we'll start to make some exponential graphs. Okay, here we've made a t-chart of values, and we've made some points from the values. At the bottom of the page here we have a little discussion about why the y values will never be negative. And then you can connect the dots and go ahead and make your graph. As you move forward, you see that the domain is all real numbers, because you can stick any number into the function. The range is all the numbers bigger than 0, and that's because the y values start just above 0 and go up. The y-intercept is 0, 1. In this case, that's really easy, but in all of the other cases, as we become more complicated, that will be a little more tricky to figure out, but extremely important. And finally, we have this idea of asymptote, which is the imaginary line, the line that is a horizontal line in this case, and the graph gets extremely close to it. And it's at y equals 0. It will always start at y equals 0. Now, let me do an example. So here we have y equals 1.5 to the x plus 2. Notice it ends in plus 2. That moves that asymptote up to y equals 2. So we'll go ahead and make the line. Boom, boom. Now we can go ahead and figure out the y-intercept. That's pretty easy by plugging in 0 for x. In this case, that's going to be up at 3. And I went ahead and I plugged in 1 for x for the next point, but that's not really quite so necessary. But you start to make the same swoopy curve that you saw in the other example. Now that we have the graph, we can write down the domain, all real numbers. The range is all the numbers above 2. The intercept is 0, 3. And the asymptote is y equals 2. Let's look at another one. Here, it doesn't end in any plus or minus, so I added plus 0 to help you notice what's going on. Since it's plus 0, the asymptote's right there on the x-axis. Now if we stick in 0 for x, we can get the y-intercept, which is down at negative 2. We can draw ourselves a swoopy graph, and then start writing things like the domain, which is all real numbers. It will always be all real numbers. The range is y less than 0. The y-intercept is 0, negative 2. And the asymptote is y equals 0. That's because it didn't move up or down at all. All right, here's the next one. Y equals 3 to the x plus 2. Again, there's no number added or subtracted at the end, so I added plus 0 to try to make it more clear that the asymptote doesn't move up or down at all. So there we have it at 0. Oops, excuse me, let me go back a second. There we have it. The y-intercept is up at 9. If you plug in 0 for x, you get 9. Boom. There you've got your graph. The same idea of a swoopy graph there. So the domain is all real numbers. The range is all the numbers above 0. And the y-intercept is 0, 9. And the asymptote is y equals 0. All right, here's the next example. Y equals negative 2 to the x minus 1 minus 3. So we begin with noticing the minus 3. So our asymptote is down at -3. Boom, there we have it. Now we'll go ahead and figure out, let's go back, there we are. The y-intercept, if you plug in 0 for x, you should end up with -3 and a small amount there, 3.5, I believe. Boom, there's the graph. So the domain is all real numbers. The range is y is less than -3. The y-intercept is 0, -3.5. And the asymptote is y equals -3. Those are some examples to get started with. Now here we have problems 1 and 2. Go ahead and please try exercise 1 on your own. Pause the video. I'll still be here when you come back, and you can check your work. Okay, so we have -2 on the end. That makes our asymptote at -2. There we have it. If you plug in 0 for x, you should end up with 1 for y. Make the exponential growth graph there. Then start noticing things. The domain is all reals. The range is all the numbers above -2. The y-intercept is going to be at 1. And the asymptote is y equals -2. All right. Now go ahead and try number 2 on your own. Again, I'll wait a few seconds so you can pause the video. But don't worry, I'll still be here when you come back so you can check your work. Okay, so let's see. It ends in +2. So the asymptote will be up at 2. All right, there we have it. If you plug in 1 for x, you get 1.5. If you plug in 0 for x, there we have it. If you plug in 0 for x, you end up with 1.5. And we have our nice swoopy graph. So the domain is all real numbers. The range is all the numbers below that asymptote at 2. The y-intercept is 0, 1.5. And the asymptote is y equals 2. All right, that's all for the exponential growth part. Now, exponential decay. The difference between exponential growth and exponential decay is that in exponential decay, the b, or the base, is a number that's less than 1. That's the number that gets multiplied by itself a lot of times because of the exponent piece. And when you're multiplying by a number below 1, the numbers go down instead of up. All right. The same caveat about having to use all kinds of numbers, including negative numbers, to make a graph. Here's the first example. Again, because it's the first example, I made a t-chart for you. Put some dots down representing the dots from the t-chart. Then you can go ahead and connect the swoop. Same basic things happening. The domain is all real numbers, just like before. The range is all the numbers above that end asymptote spot. The y-intercept is 0, 1, just like before. It's pretty obvious in this basic example. When the examples become more complicated, though, that y-intercept is extremely important. And then we have this asymptote at 0. Again, the graph becomes extremely close to 0, but it will never, ever quite get there. This graph, by the way, is the same shape exactly as the growth graph. However, in this case, it's backwards instead of forwards. Here's an example. So, the +2 makes our asymptote at 2. There we have it. Then plug in 0 for x, and in this case you end up at 3. We can go ahead and just go straight draw that swoopy graph there. But remember, now it swoops down to the right, or it swoops toward the asymptote to the right. So the domain is all real numbers. The range is all the numbers above 2. The y-intercept is 0, 3, and the asymptote is at y equals 2. Okay, now for the next one. -2 times 2/3 to the x. This one doesn't end in anything, so I added a +0. So the asymptote is, in fact, still on the x-axis. If you make, let me go back. Here we have it. If you plug in 0 for x, you should end up with -2 for y. Swoop toward the asymptote to the right, because 2/3 is the base here. It's below 1. The domain is all real numbers. The range is all the numbers below 0. The y-intercept is 0, -2. And the asymptote is at y equals 0. All right, moving forward. The next one, we have y equals 1/3 to the x minus 2. Again, I threw in a +0. I wrote it down this time. So the asymptote is still at 0. If you plug in 0 for x, you end up with 9 for y. It's a little tricky about negative exponents and fractions, so it's worth either punching straight through on your calculator or slowing down and enjoying all the long practice you can have with exponent rules. Now, there we have our general swoop shape. In this kind of case, in fact, all of these cases, we don't care too much about the exact shape here. If we wanted to be more specific, we could go ahead and make a t-chart. This is just an example of it going down toward the asymptote. Domain is all real numbers. The range is y is greater than 0. The y-intercept is 0, 9. We already see that. And then the asymptote is at y equals 0. Okay, now, one last one for me to do for you. This time it ends in -3. So our asymptote will be down at -3. If you plug in 0 for x, you end up with -3.3 for y. And then you go ahead and draw the swoopy graph where it goes toward the asymptote to the right, because 0.3 is our base, and that's smaller than 1. All right, the domain is all real numbers. The range is y is less than -3. The y-intercept is 0, -3.3. And the asymptote is, in fact, at y equals, there we have it, y equals, what did I write here? Oopsie daisy, I wrote y equals 0. That's wrong. It should say y equals -3. My apologies. Okay, finally we have numbers 3 and 4. Please go ahead and enjoy trying number 3 on your own. I'll wait a few seconds so you can pause the video and then come back to it, check your work. Okay, this one ends in +2, so our asymptote is up at 2. Then, let's see here. If you plug in 0 for x, you end up at -1 for y. Swoop up to the asymptote. The domain is all real numbers. The range is all the numbers below 2. The y-intercept is 0, -1. And the asymptote is y equals 2. Now go ahead and try number 4 on your own. Again, I will pause and wait a few seconds for you to pause the video so you can try it yourself first. Okay, let's see what we have. This time, the equation ends in -2, so our asymptote is at -2. Zoop, 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 zoop. Then if you plug in 0 for x, there we go. If you plug in 0 for x, you end up at -1.5. There's the dot. There's the swoop to the asymptote. The domain is all real numbers. The range is all the numbers above -2. The y-intercept is 0, -1.5. And finally, the asymptote is y equals -2. That's it for the notes for this section. I went pretty fast. You may need to go back, listen, and pause a lot. Let me know if you have any questions. Thank you.